you yourself have come up with an innovative metric, an innovative test of LLM quality. You want to tell us about it?
I'd had this idea of trying to have models try and compete with each other, and they can build alliances, they can gang up on other models, and also they get to share their private strategy. You can play the game yourself and see how they scheme against each other, and it was so much fun to make it. I found myself super overwhelmed when I first started trying to find the right open source model to use for a problem, because there are just so many of them.
Ed, welcome to the SuperDataScience Podcast. This is a long time coming for me. We've been working together side by side for a decade.
It's, John, a total joy to be on the podcast. It's also super surreal because I've seen so many episodes, I've interacted with you so much, and now it feels like this is really happening. I'm really on the podcast.
Well, it's going to be a great one. So you're here to talk to us about AI engineering, and we have some amazing topics planned. As usual with you, you've gone over and above in terms of preparation. I think it's the most prepared I've ever been for a podcast episode, so I know it's going to be great. And for people listening, you probably get to enjoy great sound quality. If you're watching the YouTube version, you get great video quality because we are here together in person in New York, where we have worked together for 10 years. So tell us a bit about your background, how we met, and what led you to the content that you're creating now on AI engineering and LLMs.
Oh, for sure. So I guess the main thing about me is that I am a nerd. I'm a tech guy, I'm a software developer, and I'm one of these software developers that I'm also kind of competent at people management as well. And I started out my career, I worked most of my career at JP Morgan in risk management technology. And I started out as a coder, and that's something that I absolutely loved. But very quickly, I found myself getting into the ranks of middle management. And there I was in a world of PowerPoints and spreadsheets. And there are some people who say, I got to that point in my career and I realized this is what I was destined for, and I was never very good at coding. And I felt very much the opposite. I felt that this is not what I was destined for. I was meant to be coding. And so I left JP Morgan. At the time, I think I was running a team of about 300 people.
It's wild.
And doing nothing but PowerPoints and spreadsheets. And I left and went back to coding in my apartment and started a small AI startup called Untapped. And somehow I managed to convince you to come and do it with me. And so we built up this startup, which was about taking AI models and applying them to the field of talent. And we were working with some of the deep neural networks at the time and thinking to ourselves, these models are so effective at understanding the nuance of language. Can we use this to kind of encode the thought process of a really good recruiter? Take something which looks at someone's career and doesn't look for things like keywords, but looks at patterns, looks and understands what sorts of skills they bring to the table and matches them up for jobs.
Exactly.
So we used that. We built up Untapped. We were fabulously acquired a few years ago, which was a wonderful moment for us. And we then, as part of with the parent company, we spun off our second startup, and we are co-founders of Nebula.io, which is also applying AI to the field of talent.
Exactly. And I do love telling the story of exactly how we met, which was we went to the same constituent college of Oxford University. So Oxford University is made up of 39 constituent colleges. And if you go to Oxford, you must also be a part of one of these colleges. And so as an undergrad, you actually apply to the college itself. As a graduate student, like I was when I went to Oxford, you get admitted to the university, and then you pick your top two choices for college and hope that you get one of them. I got my number one choice, which was Magdalen College, and you are also a Magdalen College alumnus. People are trying to spell that. It looks like it should be Magdalene, but it's this like old Latin pronunciation. Although this is now a bit of an aside, but something that I often think about is, how do we know how people pronounce things? Like how do we know how classical Greek or classical Latin was pronounced?
It's the mystery.
So anyway, that is really an aside. But so we're both alumni of the same Magdalen College, and Magdalen College has a very active alumni community in New York. And a decade ago, I think it must have been about 2014. We met at this little alumni event in a garden in the East Village of Manhattan. And I loved your energy. You just left JP Morgan at that time and you were so excited about what you were doing. I knew that you were this brilliant technical founder that I wanted to be working with. And it's been a brilliant 10 years since.
And as you know, the side story there as well is that I am a horrible introvert and I absolutely detest going to these kinds of networking events. And my dad had seen that there was a networking event for Magdalen College in New York. And he called me up and he said, this is the kind of thing that you should really go to. And I said, these networking events are always useless. Like nothing good ever comes from a networking event. And he said, all right, I'll make one deal with you. Go to this one networking event. And if nothing good comes of it, you never have to go to another one again. But just go to this one. And I went to that networking event and the first person I met was John. And then John comes and joins on Tapped a few months later. And now I have to go to every networking event.
Yes, exactly. I wasn't necessarily going to go into that part of the story, but if you're going to divulge that on air, you're going to have to tell us your middle name on air as well.
Never happening.
So the mystery continues on that front. Okay, so yeah, this is exciting. And most recently, you've been creating content, which is amazing. I've gone to some of your live trainings in the O'Reilly program, and the O'Reilly platform rather. And you've developed a Udemy course, which we have linked to in the show notes, called LLM Engineering, Master AI and Large Language Models. And it's a bestseller.
So the first thing I'll say on this is that I was encouraged to do this by somebody I know who is a masterful educator, who is just so incredibly, has such a talent for explaining super complicated things in ways that everyone can understand in really accessible ways. And of course, yes, I refer to you. You're really amazing at this. And it's something that I've seen you do over the years, and I've been so amazed by it. And I remembered that I used to actually do tech training myself for IBM many years ago, and I used to love it. It was really great fun. It's really enjoyable explaining things. And you encouraged me to have a shot at this, and I did, and I ran some O'Reilly events, and I absolutely loved them. And so now, yes, I've got this Udemy class. It's interesting. I had this sort of fascinating realization that there is this new type of job that's come almost out of nowhere. It's a job that I call like an LLM engineer, but it's also sometimes called an AI engineer or an AI architect. And if you go onto LinkedIn and you do a search, you'll see there's about 4,000 job openings for LLM engineer right now in the US, compared to 4,800 for data science. So there's it's really very similar.
I did not know that. That is wild.
And it's it's a kind of hybrid job. It's a job that is part data scientist, part software engineer, and part perhaps what we would have called like an LM engineer or
an ML
engineer, someone that's deploying models into production. It's got a bit of all three. And this new kind of role, someone that knows how to select models, how to apply them with things like RAG and agentic AI, and then how to deploy them into production. This is a whole new kind of category. And so I thought, is there already training that covers that sweet spot? And I couldn't find anything there. And so I decided to build this Udemy class. And yeah, it's been amazing. It's really taken off. It's been there for about 6 or 7 weeks. And 14,000 people have taken it so far. I mean, by your exponential amount of
I don't know if I would have had numbers like that in that same kind of timeline. I think it's just a matter of time before you overtake me. It's such a hot topic and it's such a good course. You also were able to, by offering it as live trainings, you were able to get real-time feedback on the content, figure out what works well, figure out how to explain things even better. And so people get this nicely polished material now in Udemy.
Yeah, for sure. The O'Reilly platform has definitely given me that opportunity, as has watching much of your training, which, as I say, is absolutely phenomenal. Yep.
So I think I interrupted you as you were kind of explaining what an AI engineer is. You talked about how it's a hybrid of data science, software engineering, and ML engineering. What else? What does it involve in terms of day-to-day tasks? What are the responsibilities of this AI or LLM engineer?
So the first thing that an AI engineer has to do is select which model which LLM they're going to be using for a problem. And it turns out this is probably the most common question that I get asked, and you probably get asked it a lot too, which is like, what's the best model? What's the best LLM? And of course, the answer is there isn't like one best LLM. There's the right, there's the right LLM to use for the task at hand. You have to start by really understanding the requirements. The first step is to drill into the business requirements and use that to guide your decision process.
Yeah.
And usually there are three major categories of things that you're looking at. First of all, you're looking at the data. What's the sort of quality and quantity of data? Is it structured? Is it unstructured? You really get a sense of the data you're working with. And then you look at the evaluation criteria. What are you going to be using to decide whether or not this model is fit for purpose, if it's solving your problem? And I'm not so much thinking there of model metrics like cross-entropy loss. I'm thinking of business outcome metrics. In our case, are the right people being shortlisted for the right job for Nebula? But thinking about what you're trying to accomplish with your commercial solution and finding the metrics for that. And then the third category is the non-functional stuff. The budget, how much can you spend on training? How much can you spend on inference? What's your time to market? Do you need something next month, or can you spend 6 months building this? And this really will help steer whether you're working with closed source or open source and help you make a lot of these decisions. But often the first step before you do any of that, before you build any LLMs, is building a baseline model, something which often isn't an LLM at all. And I don't know if you remember back in the day at Untapped, before we were working with deep neural networks, at the very beginning, we actually started with like a heuristic model that was just like janky code with a bunch of if statements. But it gave us a starting point. And I don't think we ever put that in production, but it gave us something we could use and measure against our outcomes. And then after that, I remember you built like a logistic regression model, if you remember that.
Yeah. It's interesting because the time at Untapped that we were building these natural language processing, these NLP models to figure out who was a great fit for a given role, that time at Untapped covered the same period of time that deep learning burst onto the scene and became easy to use. And so while it is a good idea potentially to be building a baseline model and testing that before using some big LLM, which might be overkill for some use case that you have, we just kind of, and another constraint that often a lot of people have is it depends on how much data you have. Although LLMs have kind of turned that on its head, because LLMs can be quite performant with a small amount of data. You can even fine tune them with a relatively small amount of data. But it used to be the case historically that if you had fewer data, you would use a simpler model. And so at the very beginning of the Untapped platform, before there were any users, you don't have any real data to work with. It makes sense. Okay, let's use a heuristic platform. Now, today, it's interesting because you could actually just ask an LLM, kind of rate.
Write the code.
Or rate this profile, as opposed to, it was feature engineering that you had to do at that time, where you wrote functions to pass over whatever document was being passed into the model to pull out, okay, is software engineer, is that character string mentioned in this description? Then okay, we'll give a binary yes into the software engineer column of this. And so obviously that's really simplistic, but it did actually go some of the way, even that kind of heuristic model.
Right, and it helps you, it gives you that baseline, it gives you the sense of this is the low bar, and then as you work towards building a more nuanced LLM, you can see the benefits, you can see the improvement you make on that baseline.
And I don't think today you would recommend building a heuristic natural language model like that.
No. But a traditional machine learning model, perhaps, to start with. It's good to start with.
A logistic regression model.
A logistic regression, right.
That kind of
For
thing.
sure.
Cool. All right. So you said, I kind of interrupted you as you were saying, before you even select an LLM, you have a baseline model that you test and see, kind of give yourself an easy baseline, and then selecting the LLM is the next step.
Well, so you first have to choose whether you're going to go the closed source route or the open source route. And that's a big decision point. And I would say that almost always, the first answer is start closed source.
Exactly.
Like begin, of course, with a model like GPT-4 Mini, with something that
Do you ever feel isolated, surrounded by people who don't share your enthusiasm for data science and technology? Do you wish to connect with more like-minded individuals? Well, look no further. SuperDataScience Community is the perfect place to connect, interact, and exchange ideas with over 600 professionals in data science, machine learning, and AI. In addition to networking, you can get direct support for your career through the mentoring program where experienced members help beginners navigate. Whether you're looking to learn, collaborate, or advance your career, our community is here to help you succeed. Join Kirill, Adlan, and myself and hundreds of other members who connect daily. Start your free 14-day trial today at superdatascience.com and become a part of the community.
I would say even I would recommend beginning with the most expensive model to start. To see, because you're, in the beginning, to do a bunch of prototyping on your own, the costs are going to be so trivial to be using the most beefy. Use that full GPT-4o, see if you can do it there, and then maybe check if you're once you're thinking about going into production, you think you're going to have a lot of users. But actually, our interview with Andrew Ng recently, he said, just leave it on that really expensive model. He was like, because he was like, almost all proofs of concept that you build, even you deploy them into production, you are going to be very lucky if it costs you tens of dollars running in production initially.
Right.
So, you don't need to be worried about spending dollars or tens of dollars by switching to GPT-4o Mini. Anyway, it's just one perspective.
No, for sure. Of course, it makes total sense. I think there are some situations where you would move to open source, and maybe somewhere you would start with open source. Obviously, the one that's most common and the one that guided us at Nebula is where you have a vast amount of proprietary data which has nuanced information captured in that data. And we want to fine-tune a model that we believe will be able to outperform the frontier because we have this proprietary data set. And that's obviously a great reason to do it. You would still probably start with GPT-4o, but then you would use that to train a model. Another situation that's very common is if you have private data, you have data that's sensitive and that you are not comfortable sending that data to a third party. You're not comfortable for it to leave your infrastructure at all, despite some of the guarantees that you might get from a sort of OpenAI enterprise agreement. But in those cases, you would still want to use open source, keep the data locally, and run it on your models. There might be some situations where at inference time, you're very focused on API costs, and so you can reduce the costs by running an open source model. And then the final thing I can think of is if you're trying to build models to run on device or without a network connection, then again, you would need to work with perhaps not with an LLM, but with an SLM, a small language model like Llama 3.2 or something like that.
Nice. And I guess maybe one thing to add there, you said you can save money with open source, and that would be the case, particularly if you were doing a lot of calls at inference time. If you're going to have a small number of calls at inference time, then kind of spinning up a server with a GPU running to have that open source model run could end up being way more expensive than calling a closed source model, just the API.
For sure, depending on the number of parameters. If it turns out that your problem can be solved with a small model, then it could be quite cheap. But if you're starting to talk about Llama 3.1 405B, then yes, it's probably going to be cheaper to use GPT-4o.
Yeah, unless you have tons of volume. Okay, and there's just a few other maybe techniques here you want to talk about that AI engineers use, these kinds of key things like RAG, fine-tuning, agentic AI. These are all very trendy terms these days.
Yeah, for sure. So once a model has been selected, the next step for an AI engineer is to then figure out, okay, how are we going to optimize applying this model to the problem at hand? And of course, then the world breaks in two. You've got the kinds of things you can do at training time and the kinds of things you can do at inference time. And training optimization, that's where we began. That's all that people did maybe a year and a half ago. We were all fine-tuning models. We were using LoRa, QLoRa to fine-tune an open source model, or you can also fine-tune a closed source model as well. But increasingly, in the last year and a half, people have been using more and more inference time techniques to better optimize your model for the problem at hand. And I think that the OG of this is probably multi-shot prompting, which we were all doing way back, giving a bunch of examples, providing that to the model and say, hey, here's a few examples, and now here's the new question you're being asked. Then along came RAG. where you take the question and you then look up in your database, okay, do I have information that I could provide the model that's going to help it answer this question? And RAG has lots of fancy stuff. There's lots of techniques you can use to get better and better at selecting the right information that's going to be most likely to be useful to the model, to bias it towards giving a high accuracy result. And RAG comes in lots of flavors. There's a hierarchical RAG where you make multiple queries to your vector store to get bigger, broader documents and then more fine-tuned
That's
parts
news
of
to
it.
me. Cool.
So, for example, let's say you've got an airline has a chatbot, and someone asks the question of, I'm going to Paris this Christmas. What could I do in Paris over the Christmas time? Maybe first of all, there would be a RAG query just to retrieve all of the information about travel to Paris. Back would come a lot of information, and then a second query would select out holiday season activities, so that it could be just a little bit more precise in the context that's provided.
So the second one is doing RAG on the first round of documents that was brought back. I got you.
Exactly.
That's
cool. And there's actually another kind which is somewhat similar to that, which is called query conditioned RAG, which is a bit similar to something that we do at Nebula, which is where you take the original query from the user, like I want to go to Paris and do holiday related things, and you pass that to an LLM. And you have the LLM rewrite that in the form of a query that's going to be most applicable for RAG to query against your vector data store.
Yes.
And so that gives you that 2 rounds before you look up in the data store. Again, increases the accuracy of the context that you're providing the model.
Yes, very cool. And that has been powerful for us at Nebula for sure. And I think one thing that we may not have mentioned is that RAG stands for Retrieval Augmented Generation.
Right.
That meaning that it's a generative AI, but you're augmenting your responses by retrieving relevant documents, relevant information from potentially a vast, vast store, billions and billions of documents you could search over efficiently.
For sure. And of course, as you say, usually the way you're doing that is you're taking the question and you're passing it through an encoder LLM that's able to turn that question, that block of text, into a series of numbers. And you can think of those series of numbers as representing a sort of a point in multidimensional space, which reflects in some way the meaning of that text. And if you've also taken all of your millions of documents and you've also found little vectors associated with each one, then the idea behind RAG is you just find which of these documents are closest to this question that you're asking. And you take those documents and you just shove them in the prompt. And you say to the LLM, hey, let me provide you with some context that might help you in answering this question. And that's the idea.
Nice, yeah. And then fine-tuning and agentic AI, I think, are the remainder. Or do you want to dig into those later?
No, for sure. All topics we could spend an entire podcast talking about any of them, of course. And they're fascinating. Agentic AI is, of course, all the rage at the moment. This is such a hot topic. And agentic AI, it's a technique. There are some hallmark situations when you think, okay, agentic is going to work for me here. One of them is where you have a complex problem, and it's clear that it's going to make sense to break that down into a series of smaller steps that are each well-defined and that together will solve the bigger problem. That, of course, sounds like agentic AI. Another obvious case is when you want to be able to make use of tools. Which, for example, is supposing you're writing a model which is going to generate some code. Potentially, you want to be able to call a tool that will execute that code and then inform the LLM whether it worked or not, and it can use the tool to iterate on that solution. The third situation where you might use agentic AI is probably the hardest one to explain, and it's the case where you're trying to solve a problem where the LLM needs to sort of exist beyond the construct of a chat with a user. It's got a sort of longer lifespan than that. It's got some sort of autonomous existence. And maybe to make it concrete, an example might be, again, if we think of this airline that's having this conversation with a user that says, I'd like to go to Paris for the holidays, what can I do? They have that conversation. Maybe a few days later, the LLM detects that the ticket price to Paris has come down by $100, and it proactively text messages that same user and says, I've noticed the price of the ticket has come down. Are you now interested in your Christmas holiday in Paris? And so from that perspective, it's kind of got this existence that goes beyond this one chat conversation. And that sounds like, okay, that's an agentic AI solution right there.
Yeah, I think the key difference is agentic AI allows you to be proactive as opposed to reactive. So if you're using an LLM in a non-agentic setting, like going to ChatGPT and typing in a query, it is reacting to your query. Exactly as you said perfectly there with that example of an agentic system noticing, proactively scraping the web to look for deals, noticing that the price has gone down and notifying you.
That's a really nice way of explaining it for sure. And then there's one small recent delta on agentic AI that's very similar, which is the emergence of reasoning frameworks, which is perhaps just a way of applying agentic AI. But these are frameworks which are able to make multiple calls, usually to the same LLM, to guide it through the process of reasoning, very much like the way we see O1 Preview reasons its way through a particular thread. And so reasoning frameworks is another technique that AI engineers can use to try and get more from their models.
Very cool. So we've already touched a little bit on how selecting a model tends to be one of the biggest and most important roles for an AI engineer in order for an application to be effective. We've touched a little bit on deciding between a closed source or an open source model. Is there anything else you'd like to cover on that, or have we?
I think probably talking more about the open source part of that and about something which I love talking about, which is benchmarks and leaderboards and that stuff.
Nice.
I've really got into that. I personally found myself super overwhelmed when I first started trying to find the right open source model to use for a problem, because there are just so many of them, and it's just so hard to figure out. Aside from prototyping with all of them, try and identify which one is going to be right for the task I'm trying to work with. And of course, one of the first places you go is Hugging Face's Open LLM Leaderboard, which is just a treasure trove of useful information. But again, there's a lot to it. And so when you bring that up and you see all of this information, one of the first things that I always do is I check the box to show the number of parameters in the table, because you need to ground yourself on comparing apples and apples and seeing which sizes of models are being compared. And I also use the filter to sort of zoom in. And then you need to look at the different benchmarks and identify which of these benchmarks are going to be most relevant for the problem I'm trying to solve. And there are a lot of problems with benchmarks. There are a lot of known limitations. They can be gamed. There's plenty of examples of contamination that's happened. People are sort of overfit to benchmarks. But still, they give you a decent indication of what you're working with. And so they give you a good grounding to pick a model. And probably my favorite benchmark, if I can go right into one of them, there's a benchmark called GPQA, which stands for Google Proof Question and Answers, which is a really fun one. And they came up with this metric in a paper just over a year ago. It was November 23 that they published it. And the idea is they wanted to come up with a metric that was far out there. Something that's going to be, the models won't be able to solve this for a long time. We want to set a really high bar here. That was the thinking. So they come up with GPQA, and the idea is it is 448 difficult questions in physics, biology, and chemistry that someone who's either taking a PhD or has a PhD should just about be able to solve. And in fact, if you put it to people of that caliber, they tend to get 65% on average in the GPQA test. So 65% is like an expert human level. If you give it to normal people like me without a PhD, and you say, okay, here's the thing, you can use Google. You can spend half an hour, as much as you want, going through Google, figure out the answer to these questions. Then people will score 35%, a dismal 35%.
Eager to learn about large language models and generative AI but don't know where to start? Check out my comprehensive 2-hour training, which is available in its entirety on YouTube. Yep, that means not only is it totally free, but it's ad-free as well. It's a pure educational resource. In the training, we introduce deep learning transformer architectures and how these enable the extraordinary capabilities of state-of-the-art LLMs. And it isn't just theory. My hands-on code demos, which feature the Hugging Face and PyTorch Lightning Python libraries, guide you through the entire lifecycle of LLM development, from training to real-world deployment. Check out my generative AI with large language models hands-on training today on YouTube. We've got a link for you in the show notes.
And a key thing here is that, so when you talk about it, we're not taking any PhD saying, okay, somebody has a biology PhD and testing them on chemistry PhD questions. It's like these 448 hard science questions are segregated. When you give that 65% of PhD level humans, it's not just like, oh, this person has a PhD and therefore they're really smart and they can do all these questions. It's like, no, they can do the subset of science questions for their discipline.
That's exactly right. That's exactly
65% of the time.
65% of the time. And when this first came out, it seemed like that was a long way out. And then Claude 3.5 Sonnet came out earlier this year, and it scored around 59%. People were just shocked. Like, wow. Already it's approaching human expert level. And then a few weeks ago, the new Claude 3.5 Sonnet came out, and it's exactly 65%. It's on par with expert humanity. It's outrageous. It's so spectacular. And then, I guess it's no news to you, but O1 Preview, of course, shatters all these numbers. O1 Preview is above 70%. Already, it's above PhD level in these kinds of subjects.
And it's just the preview model.
It's just the preview model. And we believe that Orion is around the corner. That's what the rumors tell us.
Tell me about Orion.
Orion is apparently the code name for either GPT-5 or maybe it will be O2. Whatever it's going to be. Apparently, the OpenAI's next model is codenamed Orion. In fact, I think that most recent speculation is that people are starting to see diminishing returns from these models. There was an article in Bloomberg that was suggesting that maybe we won't be as blown away as we're expecting by the next OpenAI model. And it's been somewhat surprising that Claude 3.5 Opus still hasn't come out. When 3.5 Sonnet came out a while ago, we're still on 3.0 Opus. So we're wondering whether that's because it's not yet ready, not at that level yet. But anyway, the next generation of models is, I'm sure, going to push GPQA even more.
I've completely forgotten about the Opus thing, because you're right, because the way that Claude does their sizings, you've got Haiku, which is their lightweight one, like kind of like a GPT-4o mini, and then Sonnet. And it just in my head, because I've been using Claude 3.5 Sonnet and it's so great, and it does outperform Claude 3.0 Opus on so many tasks, I'd completely forgotten about that Opus, that's kind of the bigger model, and we're still waiting on it.
We are. But people are saying a couple more months early in the new year is when we will expect Orion and the next Anthropic model. And I'm sure that these benchmarks will be blown away yet again. And then if you look at the open source models on the Hugging Face leaderboard, you'll see that they are not at this level yet. Not hugely surprising. I think the winning model right now, and this changes all the time, is the Qwen 2.5 model from Alibaba Cloud.
Oh, really?
That's the leader when it comes to GPQA. It's scoring about 22%, so it's not even close, not even at the me level.
And some spellings here for I guess all of our listeners, since we don't have words to show up on the screen in the video version either. So Orion is not like an Irish last name. It's like Orion's belt, Orion. And then this Qwen that you just mentioned from Alibaba is QWEN, like Gwen, but with a Q. And it's Qwen 2.5.
Yes, the 32 billion version of it is the one that scores best in GPQA as of now. But these things change all the time, which is why it's well worth bookmarking the Hugging Face LLM leaderboard. And I guess we'll be able to add some bookmarks to the podcast notes.
To the show notes, yeah, for sure.
Lovely, because I have about 8 or 9 leaderboards bookmarked that I go to a lot, and they're such an incredible resource.
If you send us your 8 or 9, we will put them in there. Or you can maybe create a little GitHub gist with your
nice.
with your 8, and we could link to that. Your choice. We'll see what happens.
Figure it out. I'll send it to you. And if I can indulge me to go through another couple of metrics that I love that are just
Of
fun to
course,
mention
it's fascinating.
some of the benchmarks. So there's one that's called MUSR, MUSR, that you'll also see on the Hugging Face, that stands for multi-step soft reasoning. And again, this is another of these metrics. This is now about thinking through difficult problems. There's a bunch of questions that are asked to models. The one that I enjoy hearing about the most is that they are given 1,000-word short stories of a murder mystery, and they have to respond with who has the motive, the means, and the opportunity.
That's fun.
Which said, yeah, is that great? And so you'll see the results of MUSR. And so if you're looking for reasoning capabilities, that's what you would look at. Then there's a benchmark called MMLU Pro. MMLU is a very well-known metric that was used a lot for language understanding, but it was fairly
massive multitask language understanding. Yeah,
exactly. And it was criticized for that. There was certainly some contamination, and there was also ambiguity in the metric. But Hugging Face is now using one called MMLU Pro, which fixes those problems and which is a better metric. And so if you're looking for a model that can show understanding of language, then that's the metric that you would look at. And then one more that's on there, and then I'll stop with the metrics, is called BB Hard. And BB Hard, which stands for Big Bench Hard, is also, so this was another one that they came up with 2 years ago. And the idea, again, was that this would be testing for future capabilities, for things which LLMs can't do today that one day we hope they'll be able to do. And it was in response to the fact that LLMs were getting into the 90s on all of the existing benchmarks. And one example, one of the categories of questions, is about identifying whether text has sarcasm in it, which, that's a really clever, nuanced kind of test that, as of a couple of years ago, LLMs really struggled with. As of now, Claude 3.5 Sonnet scores 93%.
Wow.
Unbelievable.
Yeah.
Unbelievable. So already that this future capability is the present capability.
Yeah, it's moving really quickly, which makes AI engineering or LLM engineering a super fun field, and also evidently creating all these jobs, rivaling the number of data scientists that we have job postings for out there.
For sure. There's a different leaderboard altogether on Hugging Face that not many people know about, which is unbelievably useful, which I feel like I'm doing a public service by telling people about it. And it's called the Hugging Face LM Perf leaderboard. And it's a leaderboard that helps you understand your hardware requirements and your timing, your latency of using different sized models on different hardware. And if you go to this leaderboard, there's like tons of information there, but you have to know that there's a separate tab called Find the Best Model. And you have to click on that tab. That's where all the magic happens. That's the juicy part.
Wow.
It shows you a scatter plot. So it's a scatter plot where every dot in the scatter plot represents a model. And the x-axis is the latency. So how long will the model take to respond? The y-axis is the accuracy, the performance against benchmarks. And each dot has a size of the marker, and the size of the marker is how much GPU RAM it takes up. And you'll see all of the models out there, and you can hover over them and get the details on them. And that means that if you've got a particular hardware setup, you've got a certain box with 40 gigs of GPU RAM, and you need it to respond in a certain time, you can simply look at this diagram and pick out exactly which models you can work with. So it's a really useful resource.
Very cool. Now, in situations like we have at Nebula, where we have a completely new kind of task that, maybe we have some competitors out there that are trying to do similar kinds of things. Like, going back to the Untapped example, still today, a big part of our AI R&D involves finding the right people for the right job. And we can do that so much. We'd be imagine if we could go back in time 5 years and show the kinds of results that we have, it would completely knock our socks off. And LLMs play a big part in that. They're not everything. There's other tricks as well, but LLMs play a big part in us getting great match results back to our users. So what about, we've talked about leaderboards so far, but these leaderboards are relatively generic intelligence. Do you have any thoughts on when you have some specific problem like we have? What would you do?
Well, the short answer is that it's what data scientists like to call it's empirical, is what they sometimes
That's
say,
right.
or it's
It's such a sophisticated sounding
yeah,
word.
right. It's one that you have to learn to say that to senior management, to executives. You say, well, that's empirical, or an area of active research is the other little expression. But what it means is there is a lot of trial and error involved. A lot of what you'll do, you'll look at these benchmarks that might help you guide you towards 3 or 4 models. Maybe you're starting with Phi from Microsoft and Gemma from Google and a couple of others, maybe Quen from Alibaba Cloud and Llama from Meta. And then you will build prototypes with a subset of your data, and you will be measuring it against some of your outcome metrics that we talked about at the beginning. And you'll be using that to help guide your decision towards which model to take. And the same will apply for the different techniques. Like when you're thinking about, okay, am I going to be doing fine tuning, working at training time, or am I going to be working at inference time, working with RAG, working with agentic AI? It will again come down to some empirical work, some trial and error. There are rules of thumb. If you're focused on trying to improve the accuracy and specialist skills, then it tends to lend itself towards RAG. We talked about some of the sort of pointers towards agentic AI before. So you'll use those to guide you. But at the end of the day, trial and error, try a few things out, see what results you get.
And I guess in that context, I'd add a couple of things like you might need to create a test set, which depending on the task, you might need to create that manually, or you could actually use some of these state-of-the-art proprietary LLMs or the really big like Llama 3.1405B to be generating synthetic data that are relevant to your test case. One thing that I would suggest that you be careful about in that circumstance is to be sure that your simulated data cover the range of use cases that you anticipate your users will have. So if you were to naively go to Claude 3.5 Sonnet and say, our kind of problem, say, I want to create a test set of jobs and candidates, and I want you to, come up with some kind of reasonable score, for how well they match with each other. If you just naively do that, you could end up stuck in a relatively small part of the whole sample space that you might want all of your samples to come from. And so a cool trick here that we have leveraged at Nebula ourselves is to use real platform data to seed the simulation. So maybe you had users come in. So in our case, you could have a user come in and say, find me a data scientist in New York. That isn't a very rich query for testing our test data set, but we could have that be the starting point, that piece of information, and then Claude 3.5 Sonnet or whatever proprietary API or some big open source model that you're using to simulate data with can make a data scientist profile, can make data scientist jobs to match against or related jobs to score against. And then you're getting a real sense of, okay, these are the users that we have. They cover this range of industries, and you get that nice range of seeds that are representative of what your user base is looking for.
It makes total sense. There's also, there are some companies that specialize in helping with that process, both generating synthetic data and also in building real data sets. So there's Scale AI and now Scale.com that is really great at that, and that's what they do. And that also gives me an opportunity to mention that they also have a leaderboard. I'm a leaderboard bore. There's a
leaderboard.
So there's a leaderboard called the SEAL leaderboards, which they have made, which are meant to be about specifically applying models to business problems. And they've got a bunch of them. They measure things like they've got one specifically for use of tools, which is really interesting, which models are better at being able to use tools. And they've got one really interesting one called adversarial robustness. And that is specifically testing models to see how good they are at refusing to answer questions that are inappropriate and not being allowed to be led astray. And that's particularly important and relevant because if, for example, you're working on a chatbot that you're going to have as your airline's customer support chatbot, you want to make sure that people aren't going to be able to generate
Make a bomb.
have it make a bomb, or make something that's very memeable and is going to be embarrassing and be posted all over the place. And so knowing that you're picking a model that is strong in terms of adversarial robustness is something that's very helpful. So scale.com generates test data, is very useful for that, and also has some great business-specific leaderboards.
Nice. SEAL. Any other leaderboards that we must know about, Edward?
Well, if you're going to open that door, let me see. Yes, there's one called Vellum. Vellum, in fact, I would say that the Vellum.ai leaderboard is it is my first bookmark. It's my number one bookmark. It's the first one I have up, because what Vellum has, which is really hard to find when you need it, is for all of the main frontier models, the cost per million input tokens and the cost per million output tokens, and the context window size.
I actually see it's off camera, but off camera, there's a laptop that Ed left open while we're recording, and it's on that Vellum page. And so I've kind of noted it. It has context windows, model names, and input cost, in terms of million tokens. And it's funny because as you were describing this, I was like, did we already talk about this on the show? Why am I so familiar with Vellum? And it's because I've been reading about it over your shoulder.
I am a leaderboard. It's right there, always on my laptop. So Vellum AI, it's really useful. It also has a bunch of other things too. It has that BB hard metric that we mentioned before, the future capabilities. And the great thing about Vellum, comparing it to something like Hugging Face, is that with Vellum, you see both open source and closed source together. So you can see that some of the massive open source models like the Llama 405B that you mentioned is competing with frontier models. It's creeping up the leaderboards. So it's really useful to see it from that point of view. And I think, there are a couple of other leaderboards. So there's a big code leaderboard from Hugging Face, which is one where you can see how good models are at writing code. And it doesn't just cover Python coding, which is a metric that many people know, but it also has Java coding, JavaScript, and C++. So it's another really good one. And then Hugging Face has a whole ton of leaderboards. They have leaderboards for medical models that are specialized in medical domain. It has financial services leaderboards, different spoken languages, so Spanish, and Korean, and Japanese, and vision generating leaderboards. So Hugging Face has tons of these.
Very nice. And I do see there's one more on your list that I'd like to call out, which is LMSys.
Yes.
LMSYS, which is really cool because that one, instead of having, so the evaluations are in head-to-head comparisons where human users evaluate whether, output A or output B is superior given the query that they put in. And so it's a more expensive leaderboard to run to be able to collect those data. And I don't mean that you're necessarily paying the users to come, but it's just it's labor intensive. There's a lot of effort that goes into that, but it provides a unique perspective relative to a lot of the other leaderboards out there. And we have a whole episode actually about that, which is Professor Joey Gonzalez was on the show, I don't know, maybe about a year ago now. And so we'll have a link to the show notes to that episode for people to check out.
And I can mention that they've actually changed their name. It's no longer called LMSys. As of very recently, they've just changed their name, and it is, as you're seeing, it's called LMArena.ai. That is the new name of LMSys.
It's a better name.
It is a better name, but LMSys is so it's been around for so long, and everyone knows LMSys that it's hard to change that. But yes, it is now called LMArena.ai. And if you go there now, it's such a great thing for everyone in the community to do. We can all contribute to this arena by doing it ourselves and by going through and voting on a model. And I believe as of right now, the top slot is going to the very new version of Gemini 1.5 Flash.
Oh,
Gemini
really?
For the win. It's come right up to the top. Sorry, Gemini 1.5 Pro.
1.5 Pro.
Is right up at the top. And people think this might be a preview version of Gemini 2, which is expected in the next month or so. So right now, as of the time we're recording this, it may have been dethroned by the time you listen to this. But as of now, that is at the top.
Well, all of this talk about other leaderboards and competitions evaluating LLMs, you yourself have come up with an innovative metric, an innovative test of LLM quality. You want to tell us about it?
Well, thank you for bringing that up. So it was a super fun project that I did. It brought me great joy because I'm such a leader bore. I did decide I should try and do one myself. And I'd had this idea of trying to have models try and compete with each other, set up some very simple rules that mean that models, you'd have 4 models playing against each other. They will be given a certain number of coins. So in fact, they start with 12 coins. And in each turn, they would have to choose to take a coin from one of the other players and to give a coin to one of the other players. But before they make their decision, they have an opportunity to speak to all of the other players privately by sending them a message. And they receive the messages and they use that to decide who they will take and give. And they can build alliances, they can gang up on other models, and there is a sort of extra bonus if 2 of the players, 2 of the LLMs, decide to both gang up on the same model, then they get an extra sort of top up of coins. So they are incented to try and form alliances. And you can go, it's called Outsmart. That's what I called it, because models outsmart each other. And I have it running. I guess I'll put that link in the show notes as well. And a lot of people have run it and have played with it. And one of the really fun things about it is that you can see the trace. You can see what's going on in terms of both what they are saying to all of the other models, and also they get to share their private strategy. They're told that the other models will not be told this strategy. This is just for their own record keeping. And so they get to say what they're doing. And they do hatch plans. They are certainly devious in what they do. And it's also the case that the stronger models tend to do better. Like I was excited to see whether with that construct of rules, it would be able to separate out the stronger models from the weaker models. And so you'll see there's a leaderboard there to look at, and you can play the game yourself and see how they scheme against each other. And it was so much fun to make it. Honestly, it was just a joy.
Cool. So when I go to Outsmart and I play with it, what do I do? Like, what do I get to change as a user?
So really, all you get to do is kick off the game.
Kick off the game. So you don't choose an LLM.
No, unless. But I encourage people. You can download the code and then put in your own keys and choose the LLM.
Gotcha.
But because it's using my keys for this, I'm using cheap models in the public internet version of it. But it's very much. It's super easy to download and very configurable. So you can then have it running yourself to try out different models. As a voyeur, you kick off the game. And you can then watch while they compete. You can watch their messages to each other as they gang up on each other. And the outcome of your game then gets recorded and added to the ELO rating of the different models.
Very cool. So that gives us a nice round tour of the various ways that we can be evaluating and selecting an LLM for our task. We've talked about closed source, open source. We've talked about various leaderboards out there, including your own. Once you've selected a model and you've applied it to the problem, you know which one you'd like to use, what does an AI engineer do? Do they hand it off to another team to productionize or what?
That's a great question. And the answer is that it depends. There are different boundaries in different organizations, but it is becoming increasingly common for an AI engineer or the AI engineering team to also be responsible for productionizing their model. And again, there are a number of different ways that can happen as well. One of the ways that's very popular and that I love is to use a product like modal.com that we use at Nebula. And it's the most fabulous platform. It's called a serverless AI platform. It allows you to deploy your model so that it's running in the cloud. You can call it through an endpoint, but you can also just have Python code. And the Python code, you can run your code and it can either run your model locally or it can call out to the cloud. And the code looks almost identical. So it feels almost as if you're just running something locally. And in fact, it's calling out to the cloud. And the great innovation about Modal is that you only pay for the clock cycles that your model is actually running for. So when you call out to it, it spins up and you start paying. It will then service your request. It stays warm for a couple of minutes in case other requests come in, and then it calmly shuts down, and then you stop paying. And that's, of course, very, very useful in startup land.
We've had Eric Bernhardsen, the CEO of Modal, on the show.
Wow.
He sat right where you're sitting.
Goodness.
And we did an episode, it might be 2 years ago now. Again, we'll have that for you in the show notes. Yeah, Eric Bernhardsen, brilliant guy. And he recently posted on LinkedIn his GitHub contributions over the last year. That 7x52 matrix that people have on their GitHub profiles. It makes you feel really silly.
Wow.
It's like every day.
He is a over-deliverer. I'm sitting on a hallowed ground. That's amazing. Your Modal is a fabulous product. If anyone hasn't played, you can, because you also get, I think it's $30 of free credit every month. So there's really no excuse if you're out there dabbling with models. It's so easy and it's free to be trying out running a model on a Modal serverless endpoint. He makes it very easy to be deploying models to production. So that's one way to do it. And there are some other similar products, but I don't think others you can pay for in that way. I don't think they have that innovation. But there's Hugging Face endpoints, which are very useful. There's RunPod, it's another good one. And in fact, actually, I think you recently had Luca Antiga on the show from Lightning.ai, and they have Lightning Studios, which allows you to deploy onto their cloud, which is another fabulous platform.
Yeah, Lightning Studios makes it easy to be prototyping in a Jupyter notebook-like setting, kind of like in Colab, where you're very quickly using powerful GPUs in the cloud if you want to be for your task, but then you can seamlessly transition that to a production application. Yeah, they're doing cool work over there. We'll have Luca Antiga's episode in the show notes for you as well, I'm sure.
And then there is there's a more comprehensive kind of way that AI engineers can be deploying as well. And that is, if you are responsible for building out like a RAG pipeline, like if you've been optimizing at inference time as well as at training time, and so you've built in functionality around that, then that might be something that you're responsible for deploying that entire service. So that could be something that maybe you put into a Docker container, you're deploying Kubernetes on AWS or GCP, and you're responsible for that whole production service. And it might have multiple endpoints that the engineering team is calling into. So that's another model as well. And then to go even further in that direction, if you're working with agents and you've built out an agentic AI platform, you may have an agentic environment where you have multiple agents collaborating, and you would be responsible for deploying all of that potentially. And some of the agent platforms give you a way to sort of deploy it onto their cloud. So LangGraph, for example, has LangGraph platform that lets you deploy your full set of agents onto their cloud. And Crew AI has Crew AI Enterprise, which is another one. So you can use some of these production enterprise agent platforms to be running your agents in production.
Fascinating episode, Ed. I knew it would be. So what should people's next steps be after this episode if they want to continue learning about AI engineering or pursuing a career in the field?
Well, I would, of course, give a totally shameless plug for this Udemy class I made. It was so much fun making this class. It was such a joy. And as I say, you encouraged me to do it, and I'm super grateful. I feel like I identified that gap because I didn't see other courses out there that would give you that kind of comprehensive grounding in all of these different bits. Both the choosing the right model, the training time optimizations, the inference time optimizations, and the deployment, RAG, agentic AI. So the full package is in the Udemy course, and I do hope that some people check it out.
Yeah, but again, that's LLM Engineering, Master AI, and Large Language Models. We'll have a link to that Udemy course in the show notes. Yep, sorry I interrupted you.
Wonderful, and I would give perhaps a slightly less shameless plug, but a much greater plug for another Udemy class, which would be your Udemy class on the mathematical foundations of machine learning. And I just feel like, again, this is one of those extraordinary things. Like it's such a treasure trove of educational material that this is the kind of thing that one would need to have done a university degree in. You need to invest so much time and money in being able to learn this kind of foundational information about deep learning. And it's all available. And in fact, I think on your YouTube, you've got much of the content is free.
Yeah.
And then if you want to do the exercises and the notebooks, then you've got a value add on the YouTube
Yeah,
platform.
exactly. So there's two. So my machine learning foundations curriculum, I had a studio recorded version that Pearson, the big educational giant, they paid for me to be in a studio for 4 long weekends. It was like 15 recording days, something like that. And then they had a professional production team convert that into amazing high quality professional recordings that are fully available. The entire curriculum is available today in the O'Reilly platform. And they also very generously gave me a unique and unusual carve out where they allowed me to also record the same material at home using a webcam and publish that to YouTube and this Udemy course. Now, the downside of that and me doing it on my own is that I've only gotten halfway through. So the linear algebra is covered, the calculus is covered, and a little bit of the probability theory, but there's lots more probability theory still to come, statistics, and data structures and algorithms that still needs to get in there. So computer science that still needs to get in there in YouTube and Udemy. But yeah, it's all freely available on YouTube. We'll have a link to that in the show notes. And the only difference between the YouTube version and the Udemy version is if you want to support me a little bit, then you can buy it on YouTube. That's nice. But you also get access to fully worked solutions in the Udemy version. But all of the educational content is in either. And
I hardly need to tell your audience this, but honestly, you are so masterful at this, being able to break things down into bite-sized chunks and build on top of them. And I've seen you explaining things so many times, and it's just a tremendous resource. So.
Thank you. I really appreciate it. And actually, a question that you might have as a listener is, why do I need to learn, say, the mathematical foundations of machine learning anymore when so much can be done by LLMs? And it's amazing when you're building, training, or deploying a production AI system, there are tons of opportunities. If you can get into the nitty-gritty of how these things work and how you can deploy them, you can end up having clever things that will be specific to your application, that will be proprietary, and will actually give you a moat as well as a company.
Absolutely. Yeah, it's incredibly important to have that foundation. And you see the people that don't have that have a much, particularly if you hit a problem with training, or you're starting to see diminishing returns, and you don't have that kind of foundation that you can tie on, then it's much, much harder.
Exactly. All right. And then my 2 questions for all of my guests. Do you have a book recommendation for us?
Okay. I mean, I was prepared. I didn't know.
Pretending like you didn't know.
So first of all, I should say that I am terrible at reading. I am a really bad reader.
You're good at listening to books at the gym.
I did that for a while, but not enough. And I come from a family that are all avid readers. They are really prolific readers. I'm the sort of scientist in the family, and they are all they're highly literally skilled. And so when we have like our weekly family Zooms, and they're really split in half. The first half of the family Zoom is everybody asking me technical support questions. Why is the Wi-Fi so flaky? Why can't I read my email? And that's the first half. And then the second half is all about, oh, that's such a good read, this book, it's so good. And everyone else in my family seems to get through at least a book a week, which makes me feel hopeless.
Wow.
They do force me to read from time to time. And the most recent thing I read, which was 6 months ago, but still quite recent, is a book called Clara and the Sun.
Right.
If you know that. Yeah,
I know. I started it.
It's really so it's by Kazuo Ishiguro.
Yeah.
And it's in some ways it's not a science fiction book, but it has science fiction elements to it for sure. But he's not a science fiction writer. He also wrote The Remains of the Day, which is a super famous prize-winning book. But it's about a humanoid robot. It's set in the future. The humanoid robot is known as an AF, an artificial friend. And it's written from the first person point of view of this artificial friend, which is really powerful. And the thing about it that is so astonishing is that this book was written about a year before ChatGPT came out.
Right.
So it predates. I mean, now this kind of thing is more something that is on all of our minds.
Yeah.
But it predates ChatGPT, and that has made it so much more relevant. And it's really moving. Like I urge you to finish it.
I'll get going on it again. Thank you.
Oh yeah, it's great. Really amazing.
All right, and then quickly, as we're losing light here, recording under natural light. Though it's funny that as I said that, a lamp turned on, which is also the indicator that it's sunset. No, I was on cue. Incredible. Although not bright enough to light our faces on camera. So very last question for you is, how should people connect with you after the episode or follow your work?
Okay, well, thank you for asking that. And for me, it's simple. The best way to be in touch with me is through LinkedIn. I absolutely love LinkedIn connecting with people. You hear some people saying, if you want to LinkedIn with me, then write a short thing saying where you heard this or something.
I do that.
I'm not like that. I'm a LinkedIn bore.
You're a lion. I don't know. It stands for I can't remember what it stands for, but if you have lion in all caps in your LinkedIn description, it means you accept all requests.
I see. Well, then I'm one of those. I can't be fussy. I'm fully open for all LinkedIn requests. Please bring them on. I love being part of the community. If this has interested you, if the field of AI engineering is something which seems interesting and you have career questions, then I'm always available for you to bounce questions at any time. I'm pretty responsive as well. If you have ideas, if you have something that you're working on that involves LLMs and you're thinking, what model should I use? Which leaderboard should I consult? Or something like that, then please hit me up. I love engaging in this stuff. So connect with me on LinkedIn. That's the best way. Very generous
offer, and very generous of you to spend so much of your valuable time with us here. Thank you, Ed, for this amazing episode. It's been such a delight after 10 years of working together to have you on the show.
It's been such a joy to be on the show. I knew I'd have a blast, and I did. Thank you, John. Thank you for having me. It's been really great.
It was such a treat to finally share the incredible Ed Donner with you today. In today's episode, Ed covered AI engineering as a hybrid role combining data science, software engineering, and ML engineering skills with approximately 4,000 current job openings in the US, rivaling the number of job openings for data scientists. He talked about when selecting an LLM, you want to consider starting with closed source models like GPT-4o for prototyping, then potentially moving to open source options if you have proprietary data, privacy requirements, or high inference costs. He filled us in on how key techniques in AI engineering include fine-tuning models with domain-specific data, RAG, retrieval augmented generation, for enhancing responses with relevant context, agentic AI for autonomous proactive systems. He also talked about important benchmarks for evaluating models like GPQA for testing expert level knowledge, MMLU Pro for language understanding, and Big Bench Hard, BB Hard, for testing advanced capabilities. And then finally, he left us with deployment options for AI systems, including modal.com for serverless deployment, Lightning Studios for seamless prototyping to production, Docker and Kubernetes for full production services, and specialized platforms for agentic AI deployment. As always, you can get all the show notes, including the transcript for this episode, the video recording, any materials mentioned on the show, the URLs for Ed's social media profiles, as well as my own at superdatascience.com/847. Thanks, of course, to everyone on the Super Data Science Podcast team, our podcast manager, Sonia Brajevich, our media editor, Mario Pombo, our partnerships manager, Natalie Jajski, researcher, Serge Massis, our writers, Dr. Zara Karche and Sylvia Ogweng, and our founder, Kirill Eremenko. Thanks to all of those folks for producing another magnificent episode for us today, for enabling that super team to create this free podcast for you. We're deeply grateful to our sponsors. You can support this show by checking out our sponsors' links, which are in the show notes. And if you yourself are interested in sponsoring an episode, you can get the details on how to do that by heading to johnkrohn.com/podcast. Otherwise, share this episode with folks who'd love to learn about AI engineering. Review the show on your favorite podcasting platform or YouTube. Subscribe, obviously, if you're not already a subscriber. But most importantly, I just hope you'll keep on tuning in to more episodes in the future. I'm so grateful to have you listening, and I hope I can continue to make episodes you love for years and years to come. Till next time, keep on rocking it out there, and I'm looking forward to enjoying another round of the Super Data Science Podcast with you very soon.